Okay, so in this video we're going to find two components of a triangle. We are going to find the orthocenter and the centroid. So the orthocenter is the point inside of a triangle where all of the altitudes meet. So to find an altitude, what we need to do is we need to basically we need to draw a line that's going to be perpendicular to a side that goes to the opposite vertex. In order to do that, we need to get out our compass. So I'm going to show you how to do this using a compass. And so what we need to do first is we need to, let's say I want to find the altitude from this vertex to the opposite side. I'm going to put the pointy part of the compass there, and I'm going to extend my compass outwards. And I want to position it in such a way because I'm going to want to draw an arc that's going to go through 2 points on this side. This is a little bit tricky. Especially if you look here at this one, this triangle's pretty close to a right triangle. All right, this actually should be all right. So if I draw this arc, there we go. That's not horrible. It's going to intersect this side at 2 points, right there and right there. Once I have those 2 points, then I'm going to want to basically bisect this and draw a perpendicular bisector. So if you remember doing that before, we need to measure the distance between these 2 points and extend our compass just over halfway, maybe about there, and draw an arc. Then what we're going to do from the opposite point, not adjusting the size, we're going to do the same thing. Now here, I actually didn't make my first arc big enough, so I'm going to need to go back and make sure this lines up nicely and draw a second arc. Now if you can see, there are these 2 points there. If I were to draw a line going through these 2 points, that's how we would make a bisector, right? Specifically a perpendicular bisector. I don't necessarily want to do that because all I'm interested in is a point. So if I had a ruler right here, I would take a straight edge and I would measure right where those 2 points meet. All right, I'm going to get rid of all these extra lines here. Oops. So all of that I've done so far was just to get this 1 point. That's the 1 point that is basically bisecting that arc that I drew. Now if I draw a straight line connecting this point to the opposite vertex, this is actually going to measure 90 degrees. And you can kind of see it looks like it's about 90 degrees. This is our first altitude. We want to do this 2 more times because there are going to be 3 altitudes inside of a triangle. Where these 3 altitudes meet is where the orthocenter is. So in case we miss this, I want to go back here and I'll do the next one. So we'll do this one in green. Let's start with this vertex. And so what I'm going to do is I'm going to put the point of my compass there and extend this out. And remember, the point is that I want to make an arc so that it's going to go through this opposite side twice. It's just like that. I'm going to take note of where these 2 points, so where this arc intercepts this side. And then from those 2 points, I'm going to basically treat those 2 points as the starting and endpoints of a segment. And I'm going to bisect that segment. So I place the end of one, so I place the pointer of my compass at one point, and I extend this just a little bit over halfway, just eyeballing it. And I'm going to draw an arc, and do the same thing going from the other side. Could I actually get a ruler? I know I tried to do this in class. Then I had difficulty rotating it. Yeah. So if I had a ruler, what I would do is I would measure out the intersection point of those two arcs. And then I would place a point where that intersects on the side. Now again, I'm going to get rid of all this extra nonsense there. I now just have a point and the opposite vertex. When I draw a straight line connecting this point to the opposite vertex, I'll make sure this is the same color here. Just like that. Again, this is going to be an altitude, they're going to be perpendicular. And this does look perpendicular. It doesn't have to bisect the side. That's the key. And that's the difference between a perpendicular bisector and an altitude. A perpendicular bisector just cuts halfway through the line at a 90-degree angle. It doesn't need to go to the opposite vertex. An altitude needs to be perpendicular, needs to go to the opposite vertex. It's not going to cut a side in half. It could, but it doesn't have to. So let's get this final altitude here. So I'm going to start at this vertex, extend. Oh boy, I made that too small. My compass is not quite big enough. Well, for the sake of time anyway, if you need to go back and see how we make those altitudes, I think I've explained it. Well, I've explained it twice already, so that should be good. If we were to properly do another altitude, because our compass extends properly, again, we want to use a straight line. Don't know what that was. We start from the opposite vertex, and we want to connect at a 90-degree angle to the opposite side. And we can see that this looks like it's a 90-degree angle. That means that right here where all three of these altitudes intersect, that's the orthocenter. That's it. Now the centroid is where the medians intersect. The median goes from the midpoint of a side to the opposite vertex. We don't have to worry about the 90-degree element here, but we are going to be bisecting. So if I start with red this time, and remember to bisect, we want to extend our compass a little bit more than halfway and draw some arcs. So there's one there. If I go back to this corner, there we go. Again, we just really care about where these points intersect with the side. So you can see I found where the line would be between these 2 points, where the 2 arcs intersect. And I draw a line, or sorry, I draw a point where that imaginary line intersects with the side. I don't need the rest of that. Really, whoops. The only thing I need is this point. The median is going to be the line that goes from that point, which is halfway between the ends of the side, to the opposite vertex. Just like that. And I'm going to do that for all of the other sides as well. So let's change up my color here, do blue. I'm going to do this for each side. So why don't I do this top side now? Again, we want to make sure that this compass goes a little bit more than halfway. Draw an arc. Draw a second arc. It doesn't really matter how big or small it is. Sometimes I know some of you like to draw really thick arcs. If you apply a little bit of pressure, you get the same results, and it's going to be easier to erase. Alright, so there's my imaginary line. Again, I'm only going to care about where this line intersects with the side, and I can erase everything else. From that side, which is the midpoint, I'm going to draw a straight line to the opposite vertex. And finally, I'm going to get the midpoint of the final side. So I'm going to find out where the midpoint is on this side here. Going to figure out where the intersection line is between these two. Now where that line intersects with the side, I'm going to make a point. You don't have to erase all this extra lines. It does help eliminate any confusion about what goes where. That's why I'm doing it. If I connect this midpoint with the opposite vertex, there we go. Very nicely done, if I do say so myself. This is a centroid. This point right here, where all of the medians intersect, is a centroid. Right? So make sure you're able to work out and find, at least draw medians and altitudes. And then what you can do is you can find centroids and orthocenters.